have made another video on year 1 binomial expansion, so I'd recommend you watch that one as well if you haven't already. I'll show you the year 2 binomial expansion through doing an example. Here's the example. Expand 8 plus 12x to the power of 1/3 in ascending powers of x up to and including x cubed. And then part B, write down the range of values of x for which the expansion is valid. Starting with part A, we need to use the formula that's going to be given to you in your formula book. And the big clue that we want to use this specific formula is the fact that the power of n is actually 1/3. And if you notice here, it says n is a real number in order to use that formula. Because n is a real number, it can be a fraction or it can be negative. This is different to the year 1 binomial expansion formula, where n had to be a natural number to use that, so a positive integer. This formula is a lot more flexible in terms of the powers of n. Now, once we've established that we want to use this formula, we need to make sure that our bracket is in the correct format. You'll notice here that the formula has a 1, whereas our bracket here has an 8. This means to answer the question, we do have to factor the 8 out of the bracket first. So 8 plus 12x to the power of 1/3, we're going to write that as 8 brackets 1 plus 12 over 8x, and all of that is going to be applied to the power of 1/3. Now, it's really important that you put the 8 inside the bracket, which then has the power of 1/3 applied to it, because you need to remember to do that as well. So 8 to the power of 1/3 is in fact 2. That's a really common place to lose marks there. The rest of it can be simplified a little bit. So the bracket could be written as 1 plus 3 over 2x, and then that is to the power of 1/3. Now we're ready to sub into the formula because we have a 1 in the right place. We have our n value, which is 1/3. And then we just need to be careful that we've got 3 over 2x, whereas the formula states x. So I would keep the 2 on the outside so I don't forget about it, and then open up the brackets and start subbing into the formula. So the formula says 1 plus nx, so that's going to be 1/3 for n, and then 3 over 2x instead of x, and then plus n brackets n minus 1. So that means we want 1/3, and then 1/3 take away 1, which is minus 2/3. Over 1 times 2. Some people prefer to write 2 factorial there, it's up to you, times x squared. And once again, we don't have x, we've got 3 over 2x, so let's square that instead. The next term follows that same pattern, so we'll have 1/3 times by minus 2/3, but then we need to take away 1 again, so it's going to be times by minus 5/3. And all of that will be over 1 times 2 times 3 this time, or 3 factorial, times by 3 over 2x cubed. And we can stop there because the question just wanted us to go up to and including x cubed. We can then simplify this using our calculator where appropriate, and that will be 2 brackets 1 plus 1/2 x minus 1/4 x squared plus 5 over 24 x cubed. Then multiply the 2 through and you'll get 2 plus x minus 1/2 x squared plus 5 over 12 x cubed. And that's it for part A. Now let's look at part B. Write down the range of values of x for which the expansion is valid. Now for questions like this, which mention the validity of the expansion, we're actually going to use this fact here. The fact that the modulus of x has to be less than 1. That's referencing this x value here. Now remember, in part A, we actually expanded this, which means instead of x, we had 3 over 2x. So all we have to do is replace the x in the modulus with 3 over 2x. So the modulus of 3 over 2x has to be less than 1, which means the modulus of x would have to be less than 2/3. And that would be it for the final answer for part B. That's it for now. If you found this video useful, please do remember to like, comment, and subscribe to my channel if you haven't already. And do share this with anyone else you think might find it helpful. Thanks, and see you next time.